Well, in our previous discussions, we came to know the meaning of a allied angle, and we says that if the given angle is of the form n into pi by 2 plus or minus theta, where n is any positive integer and theta may be some acute angle, then we find minus theta, 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, 270 plus or minus theta, 360 plus or minus theta. These are all the angles allied to our original angle theta. And also in our previous discussion came to know how these angles are allied to theta when they are connected to the trigonometric functions like sine, cos, tan, and their reciprocals. So now, because this topic is very much important for your further studies also, that's why I just to summarize all the results what we proved in the previous class in the form of a table. So try to, then this table helps you to remember the results which we proved in the previous class. So for that, I just set some simple convention to remember those results in a well-defined manner. As we all know, minus theta, 90 plus or minus theta, 180 plus or minus theta, 270 plus or minus theta, 360 plus or minus theta are the allied angles. Okay, I will write those angles once again. Which are the allied angles allied to theta? One is minus theta, another one is 90 plus or minus theta, one more is 180 plus or minus theta, then 270 plus or minus theta, and 360 plus or minus theta. So now coming to the minus theta, you just remember in this rough way, this is a revolving ray. If it rotates in the anti-clockwise direction, it occupies the first quadrant. It becomes theta. So the angle generated becomes theta. Suppose the same revolving ray, if it rotates in the clockwise direction, it coming under fourth quadrant where the generated angle is taken as a minus theta. So please remember, according to ASTC rule, in fourth quadrant, only cos and its reciprocal secant is positive for minus theta. So for that reason, we write cos of minus theta is plus cos theta, secant of minus theta is plus secant theta, and all other trigonometric functions will take a negative sign on their right hand side. Like that, sine of minus theta, you will write it as a minus sine theta because sine is negative in the fourth quadrant. Cos of minus theta, it is plus cos theta because it is positive in the fourth quadrant. Like that, tan of minus theta is also negative in the fourth quadrant. Tan of minus theta is equal to minus tan theta. Now, so when we have angles of the type 90 plus or minus theta, 270 plus or minus theta, or 180 plus or minus theta, and 360 plus or minus theta, I will just tell some convention. If it seems to be easy for you, then you can follow this convention and write down the formulae and solve the problems regarding allied angles and all other chapters in the forthcoming trigonometry also. Now, first of all, before going to follow that convention, I will recall the one more basic concept, that is, we know that for sine function, its co-function is cosine, that is cos. For sine, cos is its co-function, and vice versa is also true. For cos, sine is a co-function. Similarly, for secant, its co-function is cosecant. Vice versa is also true. For cosecant, secant is its co-function. Then for tangent of an angle, so its co-function is cotangent, that is cot. For cot, again tan is its co-function. I repeat this concept. Sine and cos are the co-functions of each other. Secant and cosecant are co-functions of each other, and tan and cot are co-functions of each other. Right? Now, whenever you are going to connect an angle of the magnitude 90 plus or minus theta and 270 plus or minus theta, I repeat, whenever you are going to connect the angles of the type 90 plus or minus theta and 270 plus or minus theta, so what function you are going to connect for these angle, you have to write down its co-function on its right hand side. Suppose you are going to connect sine of a function. You are going to connect sine of a function either for 90 minus theta, 90 plus theta, 270 minus theta, or 270 plus theta. So I will take 90 minus theta. Whenever here we are going to connect sine of a function for 90 minus theta. According to our convention, whenever we are going to connect any trigonometric functions for the angles of the range 90 plus or minus theta or 270 plus or minus theta, what trigonometric function is there on the left hand side, write its co-function on the right hand side. Now 90 minus theta is coming under one of these four angles connected for sine. For cosine, the co-function is cos. Sine of 90 minus theta. You just look after the result which we proved in the last class. Sine of 90 minus theta is equal to cos theta. And also you have to decide whether the right hand side will take a positive sign or negative sign. So by following the quadrant rule of sines. For example, 90 minus theta coming under first quadrant, all are positive, therefore sine is also positive. Right? So I repeat the same convention. Whenever you are going to connect all the trigonometric, any trigonometric functions for the angles of the range 90 plus or minus theta or 270 plus or minus theta, what trigonometric function is there on the left hand side, write its co-function on the right hand side. Before that, you have to decide whether it will take a positive sign or negative sign by using a ASTC rule of sine. For example, I will take one more example. Say secant of 270 minus theta. First to write down the sign, it will avoid the confusion. Definitely 270 minus theta coming under third quadrant. 270 minus theta coming under third quadrant. Where according to ASTC rule, tan and cot only positive. Therefore, our secant is negative. It assigns negative sign on its right hand side. So we are connected secant for 270 minus theta. According to the convention, what we follow, what function is there on the LHS, write its co-function on the RHS. Therefore, it is cosecant theta. For secant, for co-function is cosecant. Therefore, secant of 270 minus theta is equal to minus cosecant theta. I hope you understand this convention. Whenever you are going to connect any trigonometric functions for the angle of 90 plus or minus theta or 270 plus or minus theta, what trigonometric function is there on the left hand side, write its co-function on its right hand side. So before that, so write whether it takes a plus sign or minus sign on its right hand side by using the ASTC rule of sines. Right? Now suppose instead of having a angles of the range 90 plus or minus theta or 270 plus or minus theta, suppose we having a angles of the range 180 plus or minus theta and 360 plus or minus theta. Now convention is very much simple when compared to the previous one. If you are going to connect any trigonometric function for the angles of these range, what trigonometric function it is there on the left hand side, write the same trigonometric function on the right hand side. I repeat, whenever we are going to connect any trigonometric function for the angles of 180 plus or minus theta, 360 plus or minus theta, so what trigonometric function is there on the LHS, write the same trigonometric function on the RHS. In this case also, whether the RHS will be take plus sign or minus sign by using a ASTC rule rule of sines. I hope you may understand. Let us take one of the example. Suppose cos of 180 minus theta, you can write. So first you just write the what sign is there on the right hand side. 180 minus theta, definitely it is coming under second quadrant. In the second quadrant, only sine and cosecant are positive. Therefore, our cos is negative. Right? 180 minus theta, when we connected any trigonometric function, what trigonometric function is there on the LHS, write the same trigonometric function on the RHS. Therefore, cos of 180 minus theta is equal to minus cos theta. Similarly, you can write tan of 360 plus theta. So when we connect tan for 360 plus theta, so first decide what sign it will take on the right hand side. 360 plus theta is coming under first quadrant. Again, it's coming under first quadrant. In the first quadrant, all are positive. Right? So 360 plus theta is connected to any function. The same trigonometric function results on the right hand side. Therefore, tan of 360 plus theta is simply equal to plus tan theta. So please try to remember and practice this convention. It will lead to remember successfully any number of formulae on the allied angles. Now let us try to, by following the same convention, let us try to fill this table. So it will be one of the practice session for you. 90 minus theta coming under first quadrant. For sine it is positive. So 90 minus theta, when we connect it to any trigonometric function, it results its cofunction on its right hand side. 90 minus theta, first quadrant, for cos also positive. 90 minus theta it is because therefore it results its cofunction. Similarly, tan of 90 minus theta, again 90 minus theta is also coming under first quadrant, where tan also assigned with a positive sign. Since the angle is 90 minus theta, its cofunction should be results on the right hand side. Therefore, it is plus cot theta. Then again 90 plus theta, it is coming under the second quadrant. Only sine and its reciprocal cosecant are positive. Therefore, sine of 90 plus theta, it is equal to plus cos theta. Cos of 90 plus theta, it is minus sine theta. And tan of 90 plus theta, it is minus cot theta. Again, 180 minus theta is there. Again, 180 minus theta is also coming under second quadrant. According to ASTC rule of sine, in the second quadrant, only sine and its reciprocal are positive. Therefore, so sine except sine, cos and tan will assign with a negative sign. So observe here 180 minus theta, when we connect 180 minus theta for any angle, the same any trigonometric function, the same trigonometric function results on the right hand side. Therefore, sine of 180 minus theta, which is equal to plus sine theta, simply sine theta also. Then cos of 180 minus theta, it is minus cos theta. Tan of 180 minus theta is also minus tan theta. 180 plus theta coming under third quadrant, where tan and cot are positive and the rest of the trigonometric functions are negative. 180 when the 180 plus theta is connected to any trigonometric function, we know that the same trigonometric function results on the right hand side. Therefore, sine of 180 plus theta, it is minus sine theta. Cos of 180 plus theta, it is minus cos theta. Then tan of 180 plus theta, it is plus tan theta, because 180 plus theta coming under third quadrant, where tan is positive. Then 270 minus theta. 270 minus theta is also coming under third quadrant, where only tan is positive and all other are negative except its reciprocal. So because we are connecting any trigonometric functions for the angle 270 minus theta, according to our convention, what trigonometric function is there on the LHS, its cofunction should be results on the RHS. Therefore, sine of 270 minus theta, it is minus cos theta. Cos of 270 minus theta, it is minus sin theta. And tan of 270 minus theta, it is plus cot theta, because for tan, cot is its cofunction, for cos, sin is its cofunction, and for sin, cos is its cofunction. Again, 270 plus theta is coming under fourth quadrant. 270 plus theta is coming under fourth quadrant. According to ASTC rule, in the fourth quadrant, only cos and its reciprocal secant are positive and all other are negative. So since we are connecting the 270 plus theta for the trigonometric function, according to our convention, what trigonometric function is there on the LHS, write down its co-function on the RHS. Therefore, sin of 270 plus theta, it is minus cos theta. Cos of 270 plus theta, it is plus sin theta. And tan of 270 plus theta, it is minus cot theta. Then 360 minus theta now. 360 minus theta, we all know that it is also coming under fourth quadrant, where cos and secant are positive and all other are negative. So according to our convention, if you connect any trigonometric function for 360 minus theta, so what trigonometric function is there on the left hand side, the same trigonometric function should be there on the right hand side. According to that convention, sin of 360 minus theta, it is minus sin theta, and cos of 360 minus theta, it is plus cos theta. Tan of 360 minus theta, it is minus tan theta. Right? Then 360 plus theta, again it is coming under first quadrant. You need not to check the sign, because in the first quadrant, according to ASTC rule, all are positive. So you have to recall once again, whenever we connect any trigonometric function for the angle of the type 360 plus theta, what angle is there on the left hand side, write down the same angle on the right hand side. So according to that convention, sin of 360 plus theta is simply sin theta, cos of 360 plus theta is simply cos theta, tan of 360 plus theta is simply tan theta. So I just write the table for the results which are obtained in the allied angles for only sin, cos and tan, because time will not permit to write the rest of the trigonometric functions also. But you can write the reciprocals of these three trigonometric functions by following the same old convention. If you understand the concept, so it is very easy for you. But if you are unable to follow this concept, so the days ahead are not very easy for your further learning. Please bear this thing in your mind. Let us try to solve few problems on these allied angles. Once again, it is a practice session for you on the results which are obtained on the allied angles while solving the problems on it. So in the examination also you can expect a few questions on it. So how the questions are there means, find the value of here for the class sake, I will say find the values of the following. Heading is find the values of the following. First one is sin of 135 degree. Sin of 135 degree. Please remember, 135 is not a standard angle. So try to convert this 135 degree in the form of an allied angle. So 135 you can write it as 90 plus something or 180 minus something. Both are right. For example, I just write 135 as the 90 plus 45. Because 90 plus 45 is equal to 135. Or you can also write 135 degree as sin of 180 minus 45. If you add 45 to 90, you will get 135. If you subtract 45 from 180, you will get 135. Both are same. Now, it is definitely a result based on the aligned angle. So you just follow the convention what I explained. 90 plus theta, you just to read it as a 90 plus theta. Definitely 90 plus theta coming under second quadrant, where sine is positive because our trigonometric function is there for sine. Therefore, sine is positive. When you have any trigonometric function for the angle of the type 90 plus theta, so what trigonometric function is there on the left side, write its co-function on the right side. Then sine is there, its co-function is cos theta. In the place of theta, it is 45 degree. So cos 45, we all know it is 1 by root 2. Therefore, the value of sine 135 degree is equal to 1 by root 2. So by following this convention also, you will get the same answer. For example, 180 minus theta coming under second quadrant. In the second quadrant, sine is positive. Since the angle is of the type 180 minus 45, so according to our convention, what trigonometric function you are connected to this angle, the same trigonometric function should be results on the opposite side. Therefore, sine is there, so write down the same trigonometric function. In the place of theta, it is 45 degrees. Right? So we also know sine 45 degrees is equal to 1 by root 2. So the value of sine 135, if you write it in the form of 90 plus theta or 180 minus theta, in both the cases, the result obtained will be the same. So in this way, you can find the value of sine 135 degree. Now next one, find the value of secant 150 degree. Find the value of secant 150 degree. So by following the previous convention, you can replace 150 as 90 plus something or 180 minus something. Both are same. If you say 90 plus 60, it is 150, or 180 minus 30, it is also 150. Both are same. Again 90 plus theta. So coming under second quadrant. In the second quadrant, secant is negative because only sine and cosecant are positive. So angle is of the range 90 plus theta. When you have a 90 plus theta for any trigonometric function, write its co-function on its opposite side. Which function is there here? Secant. For secant, what is the co-function? It is cosecant. So in the place of theta, it is 60. Therefore, secant of 90 plus theta, it is minus cosecant theta. To recall the numerical value of cosecant 60, you have to remember sine 60. Because sine and cosecant are reciprocal. We know that sine 60 is equal to root 3 by 2. So therefore you can write cosecant 60 is equal to 2 by root 3. Therefore the value of secant 150 degree is equal to minus 2 by root 3. Then find the value of tan of 210 degree. Find the value of tan of 210 degree. So like that of the previous convention, you can write tan of 210 degree as 180 plus something because it is greater than 180 degree. Or even you can write 210 degree as 270 minus theta, that is 270 minus 60. Both are same, right? I just write 210 as 180 plus 30. Now, 180 plus theta, which is coming under third quadrant. According to ASTC rule, tan and cot are positive. Here we have a trigonometric function tan, therefore it is positive, right? So when we have an angle of the type 180 plus theta for any trigonometric function, according to our convention, write down the same trigonometric function on the opposite side. So tan is there, so therefore its answer is tan theta means 30. We know that tan 30 degree is 1 by root 3. Tan 30 degree is equal to 1 by root 3. So in this way, so you are going to simplify to find the numerical value for the trigonometric functions when they are connected to some angles which are not standard angles. Find the value of sine of minus 360 plus cos of 240. Find the value of sine of minus 360 plus cos of 240. So it is in the form of sine of minus theta. Is it right? Sine of minus theta, we know that it is minus sine theta. Sine of minus theta, we know that it is minus sine theta. Plus, write down the cos of 240 degree as it is for this step sake. Now, minus, you can rewrite 360 degree as 270 plus 90, or I just write 360 plus 0 also. Both are same. When we add 0 degree to 360 degree, the answer will not alter. It will be only 360. Then cos of 240, I just write it as 180 plus something, 180 plus 60 it is. Right? Now this is minus 360 plus theta coming under first quadrant. All are positive. So therefore sine is positive. 360 plus theta is there for any trigonometric function. The same trigonometric function results on the right hand side. Therefore the answer is plus sine 0 plus into minus, it is minus sine 0. Again coming to here, 180 plus theta coming under third quadrant. In the third quadrant, cos is negative, therefore minus. 180 plus theta is there. It results the same trigonometric function on its opposite side. Therefore, it is minus cos 60. We know that sine 0 is 0. Plus into minus, it is minus. Cos 60, we know that it is 1 by 2. Therefore, answer is minus 1 by 2. Minus 1 by 2. So then, find the value of secant of minus 300 degree plus cosecant of 240 degree. Find the value of secant of minus 300 degree plus cosecant of 240 degree. Now, I just write secant of minus theta, it is secant theta, please remember. Secant of minus theta is plus secant theta because cos of minus theta is equal to cos theta. So then write down the cosecant 240. Now, you can rewrite this 300 as 270 plus 30. Right? Even you can write it as a 360 minus 60 also. It is also correct. Then plus cosecant of, instead of 240, I will write it as 180 plus 60. Chance is there to write 240 as 270 minus 30 also. It is also equally valid. 270 plus theta coming under fourth quadrant where secant is positive according to ASTC rule. When we connect the secant 270 plus theta for any trigonometric function, it results its cofunction on the right hand. Cosecant theta, that is correct. Right? Then plus 180 plus theta coming under third quadrant. In the third quadrant, cosecant is negative. When we connect any trigonometric function for 180 plus theta, the same trigonometric function results on the right side. So cosecant is there. We write cosecant theta. In the place of theta, it is 60. Now cosecant 30, we all know that it is 2 only, because when you want to have a numerical for cosecant 30, please remember it's reciprocal sin 30. We know that sin 30 is equal to 1 by 2. Therefore, cosecant 30 is equal to 2 by 1, which is equal to 2. Plus into minus, it is minus. So the value of cosecant 60, remember its reciprocal sin 60 is root 3 by 2. Therefore, its value is 2 by root 3. So if you take a LCM as root 3, the answer is 2 root 3 minus 2. So even you can take a 2 as a common factor, it is not matter. You should remember the numerical also. So what we call it as the results obtained in the right angles. Suppose someone asks you to find the values of the angles like 750 degree, right? So tan of minus 810 degree or secant of minus 1140 or sine of 1050, like that. When compared to the previous problems, observe here in all the previous problems, angles of a magnitude which is nearby 360 at most. In all those problems, you will get to 300, so 240, 330 degree, like that. All the angles which are nearly nearer to 360 degree. But in all the cases, you have any trigonometric function, whatever it may be, the angles are 750, 810, 1140, etc., which are the angles of very large magnitudes. Whenever you have a trigonometric function which is connected to an angle of very large magnitude, you just follow one simple convention. Under such a circumstance, you can write that angle in the form of some multiple of 360 degree plus or minus something. For example, so say 750 degree. 750 degree is twice more than the 360 degree, because 360 into 2 is 720. Still it is greater than 720. Therefore, I just write it as it is 2 into 360. It is 2 into 360. 2 into 360 is 720. Then remaining is plus 30. Observe here. So 750 will be rewritten as a multiple of 360 plus something. Instead of that, if you have an angle of very large magnitude, say 1050. Now, even this 1050 is more than 2 times 360, that is 750. You can say 2 into 360 is 720. 3 into 360 is 1080. It is nearer to 3 times multiple of 360. That's why I just replace 1500 degree as 3 into 360. So your 3 into 360 degree is 1080, but our angle is 1050. Definitely 1050 is lesser than 1080. Therefore, I will put minus sign. To what extent it is lesser? 30 degree. Now you can simplify. 3 into 360 is 1080. 1080 minus 30, it will give the 1050. It does not disturb the original large magnitude angle, but we are writing the angle of very large magnitude in the form of a multiple of 360 degree plus or minus something, plus or minus some angle which is adjustable to given angle without disturbing its magnitude. I hope you may understand. Now, coming to the actual problem, cos of 750 is there. So I just write it as cos of, it is 2 into 360, it is 720 plus 50. 2 into 360 is 720, 750 is there, therefore plus 30. 2 into 360 is 720 plus 30 is equal to 750. So we know how to write whenever any trigonometric function is connected to angles of very large magnitude. What is the next step is, so please remember, whatever may be the multiple of 360, whether it is 2, 3, 4, 5, any number else, etc. Whatever may be the multiple of 360, what the number indicates that our revolving line rotates how many rotations? Our revolving line makes how many rotations? 2 into 360 means our revolving line rotates twice, and still after completing the 2 rotation, it defines 30 degree. That is only the meaning. But we are not interested to know how many rotations made by the revolving ray. But what we are interested means, so in which quadrant our revolving ray is there, and in that quadrant it is defining that extent of angle. That is our convention. I mean, we are not at all interested the multiple of 360. So which we write when we connect any trigonometric function for the angle of very large magnitude. I hope you may understand. So whenever you are going to write the trigonometric functions of angles of very large magnitude, write it as a multiple of 360 plus or minus something. After writing that, you simply, whatever may be the multiple of 360, you neglect it. Whatever may be the multiples of 360, you simply neglect it. Read it as 360 plus theta or 360 minus theta according to the convention. I hope you may understand. So you can forget the multiples of 360 degree. You just forget the multiples of 360 degree. Read the rest. I just forget the multiples of 360. Read it as a cos of 360 plus theta. Right? 360 plus theta coming under first quadrant where cos is positive. So 360 plus theta is connected to any trigonometric function. Same trigonometric function results on the right hand side. Therefore, the cos of 750 is simply equal to plus cos 30. We know that cos 30 is numerically equal to root 3 by 2. Am I correct? Now, observe here, tan of minus theta it is. We know that tan of minus theta, it is minus tan theta. Therefore, it is minus tan of 810. Now, 810 is very much larger than the 360. It is nearer to 2 times 360, 2 into 360 is 720. 720 is almost nearer to 810. Therefore, I just rewrite this 810 as 2 into 360. If I made 2 into 360, it is 720. For 720, still it is lesser than 810. Therefore, by adding what amount it will equal to 810 means 720, 800, 810 means 90. If you are not following, you just simplify this equation. 2 into 360 is 720. 720 plus 90 is equal to 810. We are not disturbing the original angle. Instead of writing 810, we just write it as a some multiple of 360 plus something. According to our convention, forget the multiple of 360, whatever the number it is. According to us, so there is no 2. It is simply tan of 360 plus theta. One minus is there. We know that tan of 360 plus theta is plus tan theta. In the place of theta, it is 90 degree. So we know that tan of plus into minus is minus, so tan 90 is infinity. Right? Therefore, the value of tan of 810 is equal to infinity. So now, by following the same convention, let us try to simplify secant of minus 1140. It is in the form of secant of minus theta. Is it not? Secant of minus theta, we know that it is secant theta. Now, secant of 140 degree, we can say 3 into 360, it will use the 1080. 1080 still it is lesser than 1140. Therefore, 1080 plus 60 will fulfill. So 1140. So now forget the multiple of 360. It is in the form of secant of 360 plus theta. Secant of 360 plus theta is simply secant theta. In the place of theta, 60 is there. So secant 60 means, remember, cos 60. Cos 60 is 1 by 2. Then secant 60 is 2 by 1 means 2 only. Then, so one more is sine of 1050. 1050 you can rewrite as 3 into 360. 1080. 1080 minus 30 will give the 1050. According to our convention, forget the multiple of 360. Read it as a sine of 360 minus theta. 360 minus theta coming under fourth quadrant, where sine is negative. So sine of 360 minus theta. 360 minus theta is there. What function is there? It's same function you write on the right hand side. Therefore, it is minus sine theta means 30. So we know that the sine 30 is 1 by 2. So in this way, we are going to have a numerical value for a trigonometric function when it is connected to angle of very large magnitude. Now try to solve some other type of the problems. Find the value of sine of a plus b minus sine a. The question is like that. Find the value of sine of a plus b minus sine a if a plus b plus c is equal to 180 degree. The question is, if a plus b plus c is equal to 180 degree, then find the value of sine of a plus b minus sine a. Observe here, it is given that a plus b plus c is equal to 180 degree, right? So you can keep a plus b on the LHS itself and transfer this plus c to RHS. It will become a minus c, right? Now a plus b is equal to 180 minus c, right? So sorry, this is the answer. Question is sine of a plus b minus sine c is, right? Sine of a plus, find the value of sine of a plus b minus sine c, where a plus b plus c is equal to 180 degree. Now, so solution for the given problem, it is sine of, instead of a plus b, you can rewrite 180 minus a. Instead of a plus b, you can replace not 180 minus a, it is 180 minus c, right? A plus b is replaced by 180 minus c. Now write down the minus c as it is. It is in the form of sine of 180 minus theta. 180 minus theta, it is coming under second quadrant where sine is negative. So 180 minus theta is there, therefore the same trigonometric function results on the right hand side. Therefore, it is a sine c. Sine of 180 minus theta is equal to sine theta minus sine c. Sine c minus sine c, it is equal to 0. So in this way, you can simplify. So if a plus b plus c is equal to 180 degree, then find the value of sine of a plus b minus sine c, or even it will be extended for cos, tan, any trigonometric function. Now try to simplify one of the problem by using the concept of the allied angles. The question is simplify sine of minus a divided by sine of 180 minus A plus secant of minus A divided by cosecant of 90 plus A minus cos of 270 minus A divided by sin of 360 plus A. Simplify this equation. So let us consider the given problem: sin of minus A divided by sin of 180 minus A plus secant of minus A divided by cosecant of 90 plus A minus cos of 270 minus A divided by sin of 360 plus A. So coming to the first term, sin of minus theta, it is in the form of sin of minus theta. Sin of minus theta, we know that it is minus sin theta. In the place of theta, A is there. Therefore, it is minus sin A. Coming to the denominator, sin of 180 minus A. 180 minus A coming under first, second quadrant, where sin is positive. So sin of 180 minus A is there. Therefore, sin result to sin only. Sin A. Sin of 180 minus A is equal to sin A. Then plus. This second numerator is also in the form of secant of minus theta. We know that secant of minus theta is secant theta divided by 90 plus theta coming under second quadrant where cosecant is positive, because according to ASTC rule, sin and reciprocal are positive. 90 plus theta is there, therefore its cofunction results on the opposite side. Therefore it is secant A only. Minus 270 minus A coming under third quadrant where cos is negative. For 270 minus A, the cofunction in the opposite side. For cos, its cofunction is sin. It is the sin A divided by 360 plus A coming under first quadrant, all are positive. When you have an angle of the range 360 plus A, the same trigonometric function on the opposite side. Therefore, it is sin A. Here, minus sin A plus sin A cancels. Numerator and denominator sin A cancels. So, it is minus 1. Secant A cancels. It is plus 1. Minus into minus, it is plus. Sin A cancels. It is plus 1. Plus 1 minus 1 cancels. Therefore, the answer is 1 only. Next problem is the value of simplify cos of pi by 2 plus theta into sin of 3 pi by 2 minus theta into secant of pi plus theta all divided by cosecant of pi by 2 minus theta to sin of pi minus theta into cos of 2 pi minus theta. Simplify cos of pi by 2 plus theta, sin of 3 pi by 2 minus theta, secant of pi plus theta, all divided by cosecant of pi by 2 minus theta into sin of pi minus theta into cos of 2 pi minus
Yeah. Now, remember, whenever in the place of angle there is a pi, please note that that angle is expressed in terms of radians. We all know that pi radian is equal to 180 degree. In the place of pi, you have to replace it by 180 degree. 180 by 2, it is 90. Right? Cos of 90 plus theta, we know that it is minus sin theta. How means 90 plus theta coming under second quadrant where cos is negative. Whenever 90 plus theta is there, for any trigonometric function, you have to write its cofunction. Then coming to pi is 180. 180 by 2 is 90. 90 into 3, it is 270. Now it is in the form of sine of 270 minus theta. 270 minus theta is coming under third quadrant where sine is negative. Since 270 minus theta is there, its cofunction should be result on the opposite side. Therefore, it is cos theta. Because for sine, cofunction is cos. Then pi means 180. It is 180 plus theta. So 180 plus theta, again it is coming under third quadrant where secant is negative. When the angle is 180 plus theta, same trigonometric function, you have to write on its opposite side, all divided by. So pi by 2 means it is 90. Cosecant of 90 minus theta, we know that it is secant theta because 90 minus theta coming under first quadrant, all are positive. For 90 minus theta, it's a cofunction, you should be right on the opposite side. It is sine of 180 minus theta. Sine of 180 minus theta, we know that it is simply sine theta. 180 minus theta coming under second quadrant where sine is positive. When there is a 180 minus theta, same trigonometric function results on the opposite side. Then it is 360 minus theta. Cos of 360 minus theta, we all know that it is plus cos theta because 360 minus theta coming under fourth quadrant where cos is positive. So when there is a 360 minus theta, same trigonometric function you have to write. Now this is sin theta in both numerator and denominator cancels. This cos theta gets cancels. Then this secant theta also gets cancels in both numerator and denominator. Please take care about the sign. Minus into minus it is plus, plus into minus it is minus. Therefore, the answer is minus 1. The answer is minus 1. So in this way, you have to, so by applying the knowledge of the allied angles, so simplify the angles of this kind. Then now it is required to solve one more problem like prove that square root of sine of 780 degree plus 1 plus 780 degree it is. So prove that square root of 1 plus 7 sine 780 degree divided by 1 minus sine 780 degree is equal to tan 30 degree. So it is tan 30 sine by sine, it may not work out. 1 plus sine 780 degree divided by 1 minus sine 780 degree sine may not work. So for example, you can take, instead of writing like this, it is 1 minus cos 780. It is suitable. It is 1 minus cos 780 degree divided by 1 plus cos 780 degree, which is equal to tan 30 degree. So what the question is given is prove that the square root of 1 minus cos 780 divided by 1 plus cos 780 degree is equal to tan 30 degree. Now in the LHS you have cos 780 in both numerator and denominator. For the simplification, for make the simplification easier, first to try to know what is cos 780 by applying the language of the allied angles. Now this cos 780 is 2 into 360, it is 720 plus 60, right? 2 into 360 is 720 plus 60. According to our convention, Forget the multiples of the 360. Treat it as cos of 360 plus theta. We know that cos of 360 plus theta is cos theta. We know that cos 60 degree is equal to 1 by 2. Therefore, cos 780 degree, it is equal to 1 by 2. Now consider the LHS. So consider the LHS. What is the LHS? Square root of 1 minus cos 780 degree divided by 1 plus cos 780 degree. This is 1 minus cos 780 degree. We know that it is equal to 1 by 2. So 1 plus, once again, cos 780 degree is equal to 1 by 2. 1 minus 1 by 2 means 1 by 2. 1 plus 1 by 2, it is 3 by 2. So this 2 in the denominator and also the numerator gets cancels. So the answer is, so this is equal to 1 by root 3. Root 1 is 1. You can call this one as equation 1. Call this as equation 2. Compare equations 1 and 2. So both the right hand side of equation 1 and equation 2 are same. If you say if x is equal to 100, y is equal to 100, you can say x is equal to y. So if this LHS is equal to 1 by root 3, RHS equal to 1 by root 3, from equations 1 and 2, you can say, so LHS equal to RHS. LHS equal to RHS. And hence the problem. So in this way, by applying the knowledge of a allied angle, we can simplify problems of this kind. Now, one more type of the problem. If if tan theta is equal to 3 by 4, if tan theta is equal to 3 by 4, where theta greater than 180 degree and less than 270 degree. If theta greater than 180 degree and less than 360 degree, then find the value of 2 sin theta plus 3 cos theta divided by 3 cos theta minus 2 sin theta. You should be very clear this problem. It is given whenever tangent of an angle is equal to 3 by 4, under what circumstance this theta should be greater than 180 degree, at the same time it is less than 270 degree. Under this circumstance, find the value of that ratio. So you should be very clear, when the theta is there under this range, greater than 180 degree but less than 270 degree, definitely theta lies in the third quadrant only. Should be clear where the revolving ray is. Definitely this revolving ray is there in the third quadrant, right? So this is theta now. What it defines? It defines the tangent of an angle. Tangent of an angle is 3 by 4 means, so draw this perpendicular to x-axis. We can say A, it is B and C. This is not theta, this is theta, I'm sorry. This is theta now. This is theta. So tan theta is equal to 3 by 5. Before going to write what is the opposite side, what is adjacent side, so which sides are positive, you have to clear. This represents the x distance left side the origin, this is negative. This represents the y distance below origin, this is also negative. This revolving line is positive, right? Now tan theta is equal to 3 by 4 means opposite to adjacent. So opposite is AB, adjacent is BC. Minus 3 divided by minus 4, it is 3 by 4, right? So you cheat, to cheat you, it is given plus 3 plus 4. Actually, it is minus 3 by minus 4. But you should be care where the angle is there. In that quadrant, what is the horizontal line, whether it is positive or negative? What is the vertical line, whether it is positive or negative? Now, to find the value of sin theta and cos theta to meet the required ratio, let us know the value of the hypotenuse side by using the Pythagoras theorem. What is the Pythagoras theorem states? Square of the longest side must be equal to sum of the squares of the remaining two sides. AB, what is AB? Minus 3. Minus 3 whole square, it is 9. Plus BC, what is BC? It is minus 4. Minus 4 whole square, it is 16. 16 plus 9, it is 25. If AC square is equal to 25, then AC is equal to only 5. Therefore, the value of the hypotenuse is 5. So from figure you can define sin theta is equal to, from figure you can define sin theta is equal to opposite to hypotenuse. It is minus 3 divided by 5. And cos theta is equal to adjacent to hypotenuse. Adjacent is minus 4 divided by 5. Right? So why I define only sin and cos means in the required ratio we need to have the numericals for sin of a function and its co-function cos. That's why I just to define sin and cos by using a figure. Now, so recall the give a required ratio 2 sin theta plus 3 cos theta divided by 3 cos theta minus 2 sin theta. Now 2 into what is the value of sin theta? It is minus 3 by 5. It is minus 3 by 5 plus 3 into what is the value of cos theta? It is minus 4 by 5. Right? Whole divided by 3 into minus 4 by 5 minus 2 into minus 3 by 5. Right? So in the numerator, you just take 5 as a LCM. It is minus 6 minus 12. Divided by the denominator also 5 is the LCM. It is a minus 12 plus 6. This 5 gets cancelled. Minus 6 minus 12, it is minus 18. Minus 12 plus 6, it is minus 6. Therefore, answer is 3. So in this way, you have to find the required values by using a given data. The care should be taken where the angle is. In that angle, what is the sign attained for the horizontal line and vertical line? Then proceed the further part of the business. Now, what type of the problem? Now, same type of problem. One more is if sin theta is equal to minus 12 by 13. If sin theta is equal to 12 by 13, where theta greater than 270 degree, but it is less than 360 degree. Theta greater than 360 degree, greater than 270 degree, but less than 360 degree. Then find the value of tan theta plus cot theta. Find the value of tan theta plus cot theta. That's all. Now sin theta is equal to minus 12 by 13, where theta lies under the angle which is greater than 270 degree but less than 360 degree. Definitely is the angle coming under fourth quadrant only, right? Greater than 270, less than 360, right? So this is the revolving line. This is the angle theta. Now to define the trigonometric function, drop a perpendicular to the x-axis. You can say this is A, this is B, this is C. Which is positive? This is positive, right side the origin. This is negative, below the origin, then it is positive. right? What is given? Sin theta is equal to minus 12 by 13. So sin theta can be defined as opposite to hypotenuse. Opposite is 12. Hypotenuse is 13. So unknown side is adjacent. Again apply the Pythagoras theorem. AC square is equal to AB square plus BC square. We want to have a value of a AB. Therefore, you can write AC square minus BC square is equal to AB square. AC square minus BC square is equal to AB square. AC is what? AC is 13. 13 square is 169. 13 into 13 is 169. Minus BC. What is BC? Minus 12 whole square. It is 144. So 9 minus 4 is 5. 6 minus 2 is 4 is 2. 1 minus 1 is 0. This is AB square. Therefore, AB, you can say it is 5. Therefore, this adjacent phi side for theta is 5. Now, required question is very simple. What is the value of tan theta plus cot theta? What is tan theta with respect to this figure? Opposite to adjacent. It is minus 12 divided by 5. Plus, what is cot theta? Cot theta is adjacent to opposite. It is 5 divided by minus 12. So you can take minus plus into minus. That's how. Okay. 60 is the LCM. 5 12s are 144. Plus into minus it is minus 12 5s are 5 5s are 25. So 5 4 minus it is 9 6 1 divided by 60. Minus 169 divided by 60 is the value for the required ratio. So in this way, we are solving few problems on the allied angles. In the next class, so if time permits, I will continue some other problems on the allied angles. And so, okay for the today's class. Thank you.